The outer provinces of the galaxy revolve more slowly than the inner regions. As a result, gas and dust pile up in spiral patterns. These places of greater density are where young, hot, bright stars form, the stars which outline the spiral arms. These hot stars shine for only 10 million years or so, and then blow up. But as the stars which outline a spiral arm burn out, new young stars are formed from the debris just behind them, and the spiral pattern persists. The sun, marked here with a circle, has been in and out of spiral arms often in the 20 times it has gone around the Milky Way. In this epoch, we live at the edge of a spiral arm. We've looked at internal galactic motion on a small scale across 1 million light years or less. But the motion of the galaxies themselves across billions of light years is different. That motion is a relic of the Big Bang. The key to cosmology, the study of the entire universe, turns out to be a commonplace of nature, an experience of everyday life. Imagine a moving object sending out waves. It could be light waves, it could be sound waves, it could be any kind of wave. When that moving object passes us, we sense a change in pitch. That's called the Doppler effect. If you're the engineer in the cab, then the pitch of your locomotive whistle always sounds the same to you. That's because you're moving along with the source of the sound. But if you're standing alongside the track when the train passes, you hear that familiar shift in pitch, the Doppler shift. The reason this happens is easy to understand once you visualize the waves. A stationary train sends out sound waves in perfect circles like the ripples on a pond. Let's start the train again. Now, the waves spreading out ahead of it get squashed together, and those spreading out behind it get stretched apart. The compressed waves have a higher frequency or pitch than the stretched out waves. The same thing is true for light waves. Color is to light precisely what pitch is to sound. Compressed light waves are made bluer, they're blue shifted. Stretched out light waves are made redder, they're red shifted. At the speed of a train, you can sense the change of pitch for sound, but not for light. The train is traveling about 1 million times too slow for that. It turns out that the Doppler effect for light waves is the key to the cosmos. The evidence for this was gathered unexpectedly by a former mule team driver who never went beyond the 8th grade. During the second decade of this century, the world's largest telescope was being assembled on Mount Wilson, overlooking what were then the clear skies of Los Angeles. Large pieces of the telescope had to be hauled to the top of the mountain, a job for mule teams. One of the drivers was a young man named Milton Humison, the ne'er-do-well son of a California banker. But he was bright and naturally curious about the equipment he had carted up Mount Wilson, and after the telescope was completed in 1917, he managed to stay on here as janitor and electrician. One evening, so the story goes, the observatory's night assistant was ill and Humison was asked to fill in. Humison was a gambling man, celebrated for his skill at poker and at the pool table, but his touch with the telescope was admired even more. He discovered he had a natural talent for using astronomical instruments. He became the virtuoso of the 100-inch telescope. In this instrument, the light from distant galaxies is focused on a glass photographic plate, by a great encased mirror 100 inches across. By the late 1920s, Humason was making observations himself.
Mr. Nelson?
Humason by now had his own night assistant to help him with the observations.
Afternoon, Mr. Nelson.
Good afternoon, Mr. Humason.
We'll start at 6. I'll be making a spectrogram at the Cassegrain focus.
Yes, sir.
The telescope must be able to point with high accuracy to a designated region of the sky and to keep on pointing there. A machine weighing about 75 tons, as massive as a locomotive, must move with a precision greater than that of the finest pocket watch. Everything must be checked thoroughly. The electrical power system must work flawlessly. Hours before observations are to begin, the dome is opened to allow the temperature inside and outside to be equalized. Humason prepared the sensitive photographic emulsions sheathed in their metal holders to capture with the giant telescope the faint light from remote galaxies. This was part of a systematic program which Humason and his mentor, the astronomer Edwin Hubble, were pursuing to measure the Doppler shift of the light from the most distant galaxies then known. But the most distant galaxies are very faint. That's why, even with the largest telescope in the world, it was necessary to take very long time exposures, often lasting the whole night, and sometimes requiring several successive nights. Humason would give the night assistant the celestial coordinates of the target galaxy. Through the long, cold night, he would have to make fine adjustments so the telescope would precisely track the target galaxy. The galaxy itself was much too faint to see through the great telescope, although it could be recorded photographically with a long time exposure. So the telescope would be pointed at a nearby bright star and then offset to a featureless patch of sky from which, over the long night, the light from the unseen galaxy would slowly accumulate. The telescope focused the faint white light from the galaxy into the spectrometer, where it was spread out into its rainbow of constituent colors. The spectrum would be recorded on the little glass plates.
All right, would you clamp in the drive and salute the focus star, please?
Are you clear? I'm going to salute to the east.
Yes, I think I'm clear. Just take it easy. All right, I have it. Now let's go to NGC 7619. I'm clear. Going to do a 10-hour exposure. What time is it?
7:15.
All right, lights out, please. Dark slide is open.
A large telescope views only a tiny patch of sky. As the Earth turns, a guide star or a galaxy would drift out of the telescope's field of view in only a few minutes. Humason had to stay awake, tracking the galaxy while elaborate machinery moved the telescope slowly in the